Factoring trinomials of the form x squared plus bx plus c. So here we have trinomials, three terms, 1, 2, 3 terms. To factor these, if they factor, step one, always, no matter what kind of polynomial you're dealing with, look for a GCF first. Okay, then to factor these, this type, you are going to find factors of c. Find factors of c that add to b. Okay, so find factors of this last term, this constant term, that add together to be the coefficient of the middle term, b. Okay, so with that in mind, on these, on a, for example, there is no GCF first. Second, since it's a trinomial of this form, x squared plus bx plus c, meaning there's a number in front of the x, and there's a number at the end, but there's the coefficient of x squared is just 1. So sometimes these are called leading one trinomials. Matter of fact, I'm going to start calling these leading one, meaning the trinomial has a leading one coefficient. The leading term has 1 for its coefficient. So these are leading one trinomials. If it's of this type, we're going to find factors of c, in this case 30, that add to be 11, b. Okay, so factors of 30 are numbers that multiply to be 30, so you could try 1 times 30. Well, since those add to be 31 and not 11, that's not it. So let's move on to 2. Does 2 divide into 30? Yeah, 15 times. So 2 times 15 is 30. When you add 15 and 2, you get 17. That doesn't work. You could try 3. 3 times 10 is 30. When you add those, you get 13. So that's not it. 4 doesn't work, doesn't divide. 5 does. 5 and 6. And 5 plus 6 is 11. So that's the correct two factors of 30 that add to be 11. So what you do is you're going to split this up into two binomials. And you're going to take your first term, x squared, and split that up into two factors to be the leading term in each binomial. Next, you're going to put your factors that you found, 5 and 6, positive 5 and positive 6. I've just factored that trinomial, that leading one trinomial. You can always check your work. You can FOIL it or distribute it back out and see if you get the original. And so you could see by multiplying it back out using the FOIL method, plus 5x and then plus 30. And you can see I get x squared plus 11x plus 30. So that did work. So my answer is x plus 5 times x plus 6. So I'm not going to check these for the rest of them, but I'm just showing you that you can check your answer. Okay, so let's move on to the next one. All right, this is a leading one trinomial. There's no GCF. I'm looking for factors of 10 that add to be 7. So 10, factors of 10 would be 1 and 10, 2 and 5, and since 2 plus 5 is 7, that's it, 2 and 5. So I'm going to split this up into two binomials. My y squared is going to occupy the first two spots by splitting it up, y and y. And then the 10 is going to take up the next two spots with the two factors we found, 2 and 5. Now you may be thinking, where did the 7 go, though? Which is a common problem, common misconception. It's there, it's just I would have to multiply it out to see it. So the factors of y squared and 10 give you the middle term if you were to multiply it back out. Like I said, I'm not going to multiply all these back out, but you can see you'd get y squared, 5y, and 2y. There's your 7y, and there's your 10. Okay, so you're not going to see the middle term in your answer, but it's there if you FOILed it back out. Okay, this is a leading one trinomial. There's no GCF. This time I'm looking for factors of -4. In other words, one of the factors is positive, one of them is negative. That add to be positive 3. So I got 1 and 4. Now I need to put a negative on one of them. So since my middle term is positive, and I know that if I'm adding opposites, the larger factor, the larger term I should say, determines the sign of the sum, then since I need the sum to be positive, I know I want the 4 to be the positive and the 1 to be the negative. Those multiply to be -4. And when you add them, you get positive 3. So that's the correct set of factors. So you're going to do this, just like on the other ones. You're going to split up your x squared, just like on the other ones. Now, instead of plus and plus like we had here, you're going to have a -1 for one of them and a +4 for the other. It doesn't matter which factor goes first. You could say x plus 4 times x minus 1. That works just fine. So there's my factored form. Again, you could check your answer if you wanted to. All right, so let's move on to the next one. So this is a leading one with no GCF. We're looking for factors of -21, negative again. So one's positive, one's negative. That add to be a negative this time. So I know the larger factor needs to be negative. So you got 1 and 21, and the larger one needs to be negative. That doesn't work. That equals -20, not -4. So let's try 2. Well, 2 doesn't divide into 21. 3 does. 3 and 7, where the larger one's negative. And those, in fact, add to be -4. That's it, 3 and -7. So we're going to put our two binomials. Split up your x squared, your first term, with x and x. Split up your last term with those two that you found, a +3 and a -7. Again, it doesn't matter which one. As long as the minus is on the 7, it doesn't matter which one goes first. Okay, let's try it again. This time we're going +30, so the signs need to be the same. Now, they need to add to be a negative. So that tells me that when I try these, I need them to both to be negative. That way they add to be a negative, but still multiply to be a positive. So that adds to be -31. That's not it. So let's try -2 and -15. That adds to be -17. We're getting closer to -13. -3 and -10. That's it right there. They multiply to be a +30, but they add to be a -13. So we can go ahead and put our set of parentheses here. Split up our x squared like that, and then put our -3 and our -10, and we're done. Okay, again, on this one, we have factors of +32 that add to be a -1. -1. So I know they both need to be negative to multiply to be a positive, but add to be a negative. So it's not going to be -1 and -32, obviously. Matter of fact, there's nothing that's going to work that you're going to get a -1, right? Because the two factors are always going to add to be something greater than -1. 2 and -16. So logically, we're always going to get something bigger than 1. So we can just stop right there. We know that's not going to happen. So it doesn't factor. The answer is prime. Prime just means that it's unfactorable. Okay, so let's move on to this one. We have 16 positive. We know that we have to have a sum of +17. So the signs are the same, and they have to be positive to get a +16 for when you multiply them, but a +17 when you add them. And sure enough, the first one we try, 1 and 16 works. So we can go ahead and split these up, and then split your m squared up in the first two spots, and your 16 up in the second two with the two numbers we found. Okay, this next one, h, we're just going to rearrange this a little bit. It's just out of order. We need a +x squared first. We need our +5x in the middle, and then our -14 at the end. So you just need to make sure they're in order. Okay, so next we're looking for factors of -14. So we know the signs are different to get a negative product, and the sum is going to be a positive. So the bigger one's positive. So -1 and a +14, that doesn't work. That gives you 13. -2 and 7 multiply to be -14, and they add to be +5. So that's it. So we can go ahead and split up our x squared, put a -2 in one, a +7 in the other, and we're done. Okay, moving on. Okay, this one looks weird because we have an a in the first term, a b in the second term, and then both a and b in the middle term. So this is a common pattern. It's okay as long as it's a squared, then as long as it's a squared, a to the first, and then no a. And then at the end, it's b squared, a b, and then no b. As long as it's in that format, we're good to go. And the way that's going to look is we're going to ignore the b for now. We're just looking at 40, +40. Factors of that add to be +13. So 1 and 40 doesn't work. 2 and 20 doesn't work. That's 22. 3 doesn't divide. 4 and 10 is 14. That doesn't work. 5 and 8 does equal 13. So that's the correct set. And when you split this up, you're going to split your factors of a squared like we did we're going to split our factors of 4, not just 40, but 40b squared with these two numbers. So a positive 5, but we're also splitting the b squared, so 5b, and then positive 8, but we need to put a b on that as well. That way this equals 40b squared when we multiply it. And again, the ab in the middle happens when you multiply it out. So you get your a squared. See, there's 8ab and 5ab. There's where you get 13ab, and then 40b squared. So a plus 5b times a plus 8b. All right, so factor out the GCF, then factor. So like I said, you always check for a GCF before you factor. So in the first set, we didn't have any that had GCF. So this one does. So you don't find factors of 28 because you forgot. We always look for a GCF first. So all three terms divide by 2. So you can take out a 2. That's the GCF. Divide each by 2 like we did in class, and you're going to get this. And then you're going to try to factor this leading one trinomial that's in the parentheses. So we're looking for factors of 14 that add to be negative 9. So they multiply to be a positive 14, but add to be a negative 9. So you know it's negative negative. So negative 1 and 14, does that work? No, that's negative 15. Negative 2 and negative 7, that multiplies to be positive 14, adds to be negative 9. That's it. So we can split this up, x here, and then our negative 2 and our negative 7 like that. But that's going to be an incorrect answer because we factored a 2 out at the beginning, so that's part of my answer too. So there is my final answer right here. Okay, so let's try that again. So here I can factor a 3 out, divide each one by 3, and you get this. Now we're looking for factors of negative 3 to see if this leading one inside of the parentheses, see if factors. Factors of negative 3 that add to be positive 2. So you know the signs are different, and the bigger one is positive. So negative 1 and positive 3, and that works. That gives you positive 2. So again, we're going to split this up. X in both, and then minus 1 in the other, one of them, and then plus 3 in the other. And then don't forget your GCF at the beginning is part of your answer. So there we go. Okay, let's skip some of these just for sake of time. Okay, let's look at F right here. So on F, it is in descendant order for the variable x cubed, x squared, x. Okay, but there is a GCF. They all you can take out an x. Now, when you're factoring, the factoring patterns that we're learning will not work if your leading term is negative. So this is the first time we've seen this. So if you're factoring a trinomial and the leading term is negative, you need to factor out a negative from all three terms. So that's going to make this, dividing out a negative x is going to make that a positive x squared, and then a negative 3x, and then a negative 10. So that factoring out a negative from all three terms changes the signs. Okay, so now we're going to look for factors of negative 10 that add to be negative 3. So you know the signs are different because the product is negative 10. And you know the bigger one's negative because the sum is negative 3. So the bigger one's the negative. So if I said 1 and negative 10, if that doesn't work, you get negative 9. If I say 2 and negative 5, that works. It gives you negative 10 when you multiply, negative 3 when you add. So there you go. So we just split up our x like that, and you got plus 2 and minus 5. And don't forget, negative x needs to come down in front. Okay, so next page. We may or may not do these. I'm going to do one more example here. Let's do H. I'm not gonna task you with the fractions. Okay, so let's just do H, and we'll call it a day on the notes. So first of all, I look for a GCF, and I know they all three have one factor of x and one factor of y in common. So we divide them all by xy. That's going to give me x squared plus 10xy plus 24y squared. I just divided each term by xy. Now we're going to try to factor this trinomial, this leading one trinomial in here, finding factors of positive 24 that add to be positive 10. So that's going to be positive, positive. That's 25. That's 14. That's 11. 4 and 6 works. That's 10. So that's it. So we're going to split up our x squared and then our 24y squared with 4y and 6y. And then they were both positive. And then don't forget your GCF is part of your answer. And there's your final answer.